Hey, honors geometry students, welcome back to your next and actually last video lesson with new content. You'll have one more lesson, but new content in honors geometry. Congrats, super exciting. So in this lesson, we're going to use our knowledge of circles and emphasis on the fact that this is going to be both new and previous, right? Some things you already knew prior to geometry, and some have been new over the last 2 or so weeks. We're going to define what is known as arc length, right? And you might already start to be able to think through that logically as, oh, I know what an arc is, and I think I know what a length is, right? So maybe you've got this. And calculate missing values and measures of circles, right? So a lot of our background knowledge on solving equations, right, comes into this, and we've seen that happen as we've worked through this unit in general as well, which is a great prep for Algebra 2, which is just coming up pretty soon for you all. So what are some of the new and previous things that we knew about circles? Well, let's think, right? And so this might vary for some of you guys, but some of the things that we know about circles are, we know what a radius is, right? And that wasn't new to us. The radius is the distance from the center to any point on the outside of the circle. We knew what degrees were, right? Some of the things that we learned were we learned a little bit about central angles. Central angles. We learned about inscribed angles. We learned about tangents. We haven't talked about this a ton, but we actually did a little bit when we talked about radians, right? And so that was something that's new, and we're going to need that in this lesson. Like, what is a radian? Right? We already knew degrees. We learned about radians over the last few class periods, right? Circumference. Right? So there's a lot of things that we know about circles. So we're going to use them, and our focus is going to be on circumference, radius, and radians. And this should make sense because these go pretty hand in hand, right? So the first thing, before we get into like what is arc length, what is the difference between measure and length? And it seems like, why am I being asked this? But this is going to be really important as we move through this lesson to know what the difference between these two words are. So the measure of an angle tells us something about its intercepted arc, how much of the circle that arc is, right? Like the measure, it's 90 degrees. It's 1/4 of a circle. We don't care how big or small that circle is, but it tells us almost like the fraction, the portion, right? Like 360 degrees is a whole circle. We know that. We have an image. We have no idea how big that circle is. We have no idea what the radius is. We don't know like a distance traveled. We know like the rotational piece of it when we're talking about measure, right? So measure, we're really going to be talking about degrees and radians. So the measure of an arc is equal to, right? So here's an example of it used in a sentence. The measure of an angle, arc, is equal to the measure of the central angle that intercepts that arc. So I want you to keep in mind that this is going to involve, when we say the word measure, it's in radians or degrees. You've seen stuff like the measure of arc AC, and that little m means measure, and that's indicating to us, give me a degree measure or give me a radian measure. The length of an arc, oops, I was supposed to be in green, that's sad, is the distance, we've talked about distance, from one end point of the arc to the other, right? So like this one, we need to know how big that circle is. Right? If I'm like, you're going to drive around in a circle, we know you're going to go 360 degrees, but what length am I driving? Right? What length am I running? What length am I walking, crawling, whatever, flying, right? Like you know that a full circle is 360 degrees, but that doesn't tell us how big that circle was. And we have to stay on the outside of the circle the entire time when we're talking about this. Well, we have a word that we use for the entire length around a circle. So I'm not going to say it quite yet, Think about it. Can you think of what that word is? Right? We did this with other shapes, not just circles recently. It's important to remember that arc length and arc measure are not the same. They're talking about different things. In fact, our units would be different, right? Like this might be centimeters or inches or feet or miles, etc. Whereas this is going to be in radians or degrees. So if you're not sure what you're dealing with, check those units. Okay, so we need this. What is the measure, oh, there's that word, of the given circle? The measure of the given circle is 360 degrees or 2 pi radians, right? More of you, if you answered aloud or answering on your paper as you're watching, are probably saying 360 degrees. And I get it, right? Like I'm able to say that so easily because that's what you've known for a long time, how to work in degrees. Radians are new to us, but radians are going to be very, very helpful to us, not just in this course, but as you move forward. Okay, so I'm gonna like circle off or square off 2 pi radians, and that's gonna be our focus. So from here forward in this lesson, and when we see you next in class, when you're asked this question, answer it in radians. Okay, remember that half a circle, 180 degrees is pi radians, and that's really where this all comes from. So from that, I'm going to ask you, what is the length around the given circle? Whoa, I just asked that and gave you no background knowledge, right? So I'm saying I'm standing over here, and I'm going to go ahead and walk, and I want to know what is the length that I'm going to go. I know I'm going to turn 360 degrees. What is the length? Like, what's the distance? What's this? I was going to use the word mileage, but it's the centimeters that I'm going to walk. How many centimeters? That's what we know is circumference. Maybe you were saying that word before. Or the perimeter of the circle. Circumference is the actual word, but it's the perimeter, right? Like I'm walking around the perimeter of a building. So we find that by its 2 pi r, or pi times diameter. That simplification just comes from the fact that 2r is the diameter, right? 2 times the radius is the diameter, so we're able to use that. You can pick which one you want, right? They're both totally fine. So in this case, it's 7 pi centimeters, right? So if I do 2 times pi times the radius is 3.5, I'm going to get 7 pi centimeters. And don't you pick up your calculator and type in pi. Leave that. Leave it as 7 pi. Okay, so 2 pi radians, I'm getting 7 pi centimeters. Let's not lose that. What if I say, what about half the way around, right? 7 pi centimeters the whole way around. What's half of that? 3.5 pi centimeters. I probably didn't have to do anything, right? You probably just took this number, and I didn't even give you time. I didn't even say, hey, pause the video, and divided it by 2. Or even better, not even better, but even different, multiply by 1/2. How many radians was that? So I'm going backwards, right? The whole circle was 2 pi. Half the circle, right? I didn't even ask you for the measure. I got real specific with, hey, give me the radian measure. It's pi radians. Okay. So let's see what we have, and let's do a little more of this. Let's finish filling in this table. And so I already started it. So I'm going to do, here's the radius. Notice it didn't change for any of these. It's always 3.5 centimeters. It's one circle. And I just asked for some different fractions. No particular reason. And notice this is a little different because when we dealt with radians, we said fraction of the semicircle. Here I have written fraction of the circle, right? So a whole circle was 7 pi centimeters and 2 pi radians. Half a circle was 3.5 centimeters and pi radians. What about a third of the circle, right? I don't want a decimal. Well, I'm going to take the whole thing, 7 pi, and divide it by 3 centimeters. Look how quick that was. I took the whole thing and just divided it by 3. How neat, right? Well, how many radians is that? Well, you got to think. A third of a circle, a third of a circle, a third of 2 pi, right? I can just take this. I can go from here. Well, it's going to be 2 pi over 3 radians. Okay. What about a fourth of a circle? I'm just going to get the radians out of the way, right? The radians, we'll take 2 pi and divide it by 4. That's going to be pi over 2 radians. That makes sense. A fourth of a circle is 90 degrees, which is pi over 2 radians. Oh, okay. Well, a fourth of the arc length is going to be 7 pi over 4 radians. Oh, no, not radians, centimeters, sorry. Closed a ring on my watch and I got distracted. Okay, let's keep going. I want you to keep in mind 3.5, or we could even say 7 halves, right? Maybe we want to say 7 halves to think about it like that. Like this was 7 over 2 pi centimeters, right? That might be nicer even to look at to start to see a pattern. Maybe you already see it. Okay, 1/6 of a circle, 2 pi times 1/6 is going to give me pi over 3 radians. That's a third. So if it's a sixth of a whole circle, it's a third of half the circle. That makes sense. Half the circle's pi. Okay, a sixth of this, I'm going to get 7 pi over 6. Okay, my final one, I just went for it here, 3/4. I think that's going to be 3/4 of 2 pi. 3/4 times 2 pi. I'm going to get 6 pi over 4, which is 3 pi over 2. Well, that makes sense, right? Like, think about the quadrants. I don't know why I did it like that. 1 half, 2 halves, 3 halves, right? Remember doing that? And that was down here. 3 pi over 2 radians. Okay. 3 pi over 2. So 3/4 of 7 pi. It's going to be less than that. Well, 7/21 pi. So 7 times 3 over 4. Forgot my units. Centimeters. Okay. So what is going on here? I knew the radius was 7 halves. I knew I was dealing with 2 pi radians, right? Like those were things we knew. Well, how does that get me 7 pi? Maybe I'm not sure yet. Let's look at the one after that. Sorry, highlighting. 7 halves was the radius. Pi was the radians. 7 pi over 2 was the arc length. 7 halves was the radius. 2 pi over 3 was the radians. 7 pi over 3 was the arc length. 7 halves was the radius. Pi over 2 was the radians. 7 pi over 4 was the radius. I'm sorry, the arc length. Anything? Do you see any connection there between the radius and the radians? And then the arc length? How do I use the radius and the radians? 7 halves and 2 pi. Where am I getting 7 pi from that? 7 halves and pi. Where am I getting 7 pi over 2? 7 halves and 2 pi over 3. Where am I getting 7 pi over 3? Well, 7 halves. I need one more color. 7 halves and 2 pi over 3. Well, what if I multiplied them? No, that'd give me 14 pi over 6. Well, don't these both divide by 2? 7 and 3, 7 pi over 3. Oh my gosh, holy moly. I got this. Wait a minute, let's check it down here. I haven't even looked at this one. 7 halves times pi over 3. I get 7 pi over 6. Oh my gosh. Okay, it's got to be ironic, right? Let's try that last one. 7 halves times 3 pi over 2. 21 pi over 4. What? No way. Wow. So I can get the arc length by doing the radius times the radians. Does that make sense? Huh. Does it? It does. But why does it make sense, right? So we have this now consistent thing that was happening on our slide before. Arc length is the radius length times the radian measure of a given arc, right? Whatever arc I'm working with. Radians are unitless. So the arc length has the same units as the radius length, right? It's just a distance. If you think about it, the radians, and this goes back to when we first learned it, the radians is the number of radius lengths in a circle, right? If I take the radius and I lay it around the circle, that's one radian. So if I'm going to try to find an arc length, think about a circle, right? If I want to know, I don't know, let's just draw one out. Let's say this length, this blue length right here. Well, if I take the radius and I lay it on here, that's going to give you a length and a length, and then maybe it's like a little more, right? So if I just say, well, this length was 2.3 radians, that means it was 2.5 radius lengths. So if I had 5 of that, if my radius was 5, well, 2.3 times 5 is going to get it to you, right? It's like saying, oh, I have 5 sets of 3. How many do I have? Right? That's all you're doing there. That's all that's happening. So our arc length formula that we're going to be using and talking about is this. S is the arc length, R is the radius, and theta is the angle that's produced by the arc measured in radians. If it is not in radians, this no longer works, right? And this is why radians help. But look how simple this formula is. It's so much more complicated if I'm trying to deal with it in degrees, and it's a lot less common that you're ever going to be doing that, right? And that's why we're not throwing this in here right now, especially at this point in the year. So all I'm doing is I'm saying, well, it's the radius times the radians. It's the radius times the radians are going to give me that arc length. It's pretty cool, right? So let's do like 3 examples now. So use the given radian measure and radius length to find S, which is known as the arc length. Okay, well, S, I'm going to say I have pi over 3 radius lengths, and my radius is 3. Therefore, my arc length is pi units. This is saying, this measure basically says pi over 3 radius lengths in S. That's all it's getting at, right? It's like you're taking something angular and you're making it linear. That is what radians do for us. They're really awesome. What about this one? So it says the given sector, this is known as a sector, measures 3 pi over 5 radians. Let's go for this. 3 pi over 5 radians. Find the perimeter of the sector. Be careful with this one. I did this one on purpose. So I know this is 7 and this is 7. I want to figure out this. Well, again, this is saying there are 3 pi over 5 radius lengths. So I'll call this S. If S is going to be, there's 3 pi over 5 radius lengths, and each radius length is 7, I actually have, what is that, 21 pi over 5 inches. Okay, well, let's find the perimeter, right? I just found the arc length. I didn't find the entire perimeter. To find the perimeter, think about this is the distance you're traveling. 21 pi over 5, and then 7, and then 7 again, right? So let's make sure we account for that entire thing. So 21 pi over 5 plus 14. I'm going to use my calculator, and I'm going to use the pi button. 21 pi over 5 plus 14. I got approximately 27.195 inches. Would be that entire distance around. If I just wanted the arc length, I would certainly not go into my calculator. If I wanted an exact value, it would be this. This would be exact. This is approximate. I rounded. That's an approximation. What about this one? So use the given arc length and the radius. So now I'm giving you the arc length, right? This is S. To figure out the angle in radians, the measure of the angle in radians, right? So I have no idea, like there's theta radius lengths in 80. What's theta? What is that? Right? So I would say like, well, 32, the radius times however many they are, has got to give me 80. Right? If I divide both sides by 32, I'm just doing a one-step equation. 80 divided by 32 gives me 2.5. Right? So theta is 2.5 radians. So there was 2.5 radius lengths, right? 2.5 of these fit in this 80 unit arc. Okay. So this is a preview and an intro of it. We're going to be doing a little bit more of this in class. You do have this in your practice, your homework, your circles practice. So what we did in this lesson was we used our knowledge of circles, both new and previous, right? It was things that you maybe knew, like you probably knew circumference, you knew what a radius was, and brought in some new knowledge, especially radians, to define what arc length is and look at the difference between measure and length and calculate missing values, right? Like we worked backwards. We looked at some very basic applications, but we looked at a few examples, and we will continue to work with this when we see you next in class. Thanks everyone for watching, and we will see you soon.